Hey everyone, we're team number 72. I'm Gaurav, and my partners are Saurav, Gabriel, and Saeed. Our project is classifying paintings by artistic genre with deep learning. The artistic style of a painting describes visual and historical information. Correctly identifying the artistic style of paintings is necessary to index large artistic databases. This is a very difficult problem as standard classification tasks, such as facial recognition, rely on distinct identifiable features to classify images. Due to the broadness of paintings, we cannot rely on any definitive features. For our project, we use the WikiArt dataset, which contains 20 distinct styles from a collection of over 80,000 fine art paintings from over 1,000 artists. To solve this problem, our team is investigating the use of a deep convolutional neural network as well as improving upon existing transfer learning techniques. In order to process our data, we download the WikiArt dataset and use a Python script to randomly shuffle and select 2,000 images from each class. We then resize each image to be 128 by 128 pixels. We then split the data into training, validation, and testing sets and computed the mean of all pixel values of the training set and subtracted the mean from the pixel values in all of the sets.
We compared the performance of three models over three variations of the art style dataset using 3, 5, and 7 art styles. Our baseline model was a support vector machine. We also constructed our own CNN for comparison and also used transfer learning via ResNet. A support vector machine works by separating data points of different classes with a hyperplane of maximum margin, or maximum distance between different classes. We use a linear SVC class from the scikit-ml library with the default parameters.
We developed a CNN model from scratch, made up of 4 convolutional layers with 3x3 filters and 4 fully connected layers. Here's an image of the architecture we used with a 5-style output with 2 added residual layers in an attempt to emulate the success of ResNet. We created 2 more models, both of which are identical except for the output component, which varies depending on how many classes we want to output.
For transfer learning, we use ResNet 18, which uses 18 layers consisting of 3x3 convolution filters, downsampling with CNN with a stride of 2, global average pooling layers, and a 1,000-way fully connected layer with a softmax. In the end, we connected ResNet to 2 fully connected layers, with the last one being our output layer, which varied depending on how many styles we looked at.
Looking at the results for the baseline model, we can note a few things. For starters, the support vector machine's accuracy is quite low at 27%, indicating that the problem is indeed intrinsically harder to solve. The confusion matrix gives us some insight into why the SVM performs as such, as if we look at a very distinct art style like cubism, it has the lowest precision and recall and the lowest number of correct predictions. The model does not seem to leverage the distinct features of the art styles, judging by its cubism performance. When training our CNN for 5 styles, we notice heavy overfitting occurring quickly for the 5 styles, where our accuracy plateaus at approximately 50%. We think that since our dataset is limited in order to keep it balanced, we would need more training data to overcome this limitation. In contrast, when we train for 3 art styles, we notice that overfitting occurs as well, but it occurs slightly later. We also have a much higher accuracy in this case. This makes sense as we have less art styles and thus less complexity in what our model needs to target. For our CNN, we notice a noticeable improvement over the baseline with a final testing accuracy of 51% after a validation accuracy of 52%, indicating that our model's performance is generalizing as expected. Our CNN confusion matrix shows much better results for correctly classifying distinct art styles like cubism and romanticism. The advantage of using a CNN is that specific filters are learned for the specific art styles, but problems are introduced where styles that might have similar elements, like color or line use and distribution, are confused, like expressionism and cubism.
When training our data on ResNet 18, we ended up with a training accuracy of about 93% and a validation accuracy of about 65%. From the graphs, we see that overfitting occurs because of the complex nature of the problem, and that validation accuracy levels off after about 60%. For testing data, we achieved an overall accuracy of about 66%, which was much better than the baseline model we created. Our ResNet model predicts Cubist style paintings the best, with the style having the highest precision and the highest recall values. We think this occurs because Cubism has a distinct style with definable features that we believe is easy for ResNet to detect. Our model was the worst at predicting actual expressionism and symbolism, with expressionism having the lowest precision and symbolism having the lowest recall, which we think occurs due to the ambiguous features these styles have. We had three major takeaways from our project. First is that the prediction of art styles is an intrinsically hard problem for the development of neural networks. Second is that the hardware creates limitations on developing neural networks. And our final takeaway is that neural networks still have a long way to go in development. There are so many cases where the usage of a human expert is better than a neural network. Now we have a short demo for our models.
Welcome to our demo. We will be comparing the performance of the ResNet model against our CNN model on a dataset neither one has seen before. We will be using a 5-style dataset, with each style being represented by one image. Now let us move on and see how our CNN model does with this dataset. When looking at the confusion matrix, we can see it gets 2 out of the 5 correct, the first being Romanticism and the second being Cubism. Now let us look at the performance of the ResNet model. The ResNet model gets 4 out of the 5 correct, with the only exception being Impressionism, which it predicts as symbolism. When looking at the parameter disparity between the two models, our CNN did reasonably well, as it was able to distinguish 2 of the more distinguishable art styles in Cubism and Romanticism, while the ResNet was still having problems with the more intricate art styles such as Impressionism.